Okay, class. So let's take a look at how to create a. We're going to start off with a real basic confidence interval. We're going to make a 95% confidence interval. It's probably the most common introductory confidence interval. You'll see why in just a second. And we're going to go back to an example we talked about in class the other day. Let's suppose we took a random sample of 50 high school students and asked them what their favorite subject is. And suppose 60%. So 60% came back and said, so P hat, 60% came back and said that they prefer math as their favorite subject. We're going to go ahead and make a 95% confidence interval. And this confidence interval is going to tell us that with 95% confidence, we believe the actual population proportion, the proportion of all, for example, Pequea Valley High School students who would say that math is their favorite subject, is between these two numbers. And we're going to figure out what those two numbers is. We think from our sample it's near 0.6, but based on the central limit theorem, we can apply the central limit theorem to say that, for example, since certain conditions are met, we've got independence, we've got our sample size conditions met. If you go through and check those things, we can conclude that the distribution of sample proportions in this case would be nearly normal. So based on the normal model, from the central limit theorem, based on the normal model, we can say that this sample proportion should be within, say, 2 or 3 standard deviations of the true proportion. Well, we're going to make a 95% confidence interval, which is going to lock us in to exactly how many standard deviations this number might be from the population proportion. You're going to see how this works. So we got 0.6. The true value might not actually be 0.6. It could be some margin of error larger than 0.6 or some margin of error smaller than 0.6. We're going to find what the margin of error is and then use that to identify what we believe the range of possible values would be for the actual population proportion. So when we're done, we're going to have a lower limit and an upper limit of what we believe with 95% confidence the proportion of Pequea Valley High School students who prefer math actually is. So to get started here, margin of error is simply a z-critical value, which we'll figure out after a bit here. It's what we call a z-critical value. That's what this z with an asterisk means. It's not a multiplication symbol. It's actually kind of an exponent, an asterisk in the exponent position or superscript position. This z-critical value times the standard error for p hat. We actually already know how to find standard deviation for p hat. Standard error is exactly the same calculation. The only difference is we don't know the population proportion. We know the sample proportion. So we're not finding the population standard deviation, and because we're basing this calculation off of a sample proportion, we call it standard error instead of standard deviation. That's really the only difference. So normally standard error would be PQ over N, but for us, since we don't know P and Q, I'm going to go ahead and add in here, it's actually going to be P hat Q hat over N. Now, we want a 95% confidence interval. 95% of sample proportions should be within 2 standard deviations of the population proportion. So our z-critical value in this case is 2, because 2 standard deviations corresponds to the 95%, to the middle 95% of the distribution of sample proportions. If we were doing a 99.7% confidence interval, this number would be nearly 3, or about 3. If we were doing a 68% confidence interval, this number would be 1. And I'm going to show you how to find what the z-critical value is in the next presentation or the next video. So z-critical corresponds to the 95%, 2 standard deviations away. P hat Q hat over N, we get a standard error of 0.0693. So that part's taken care of. Now, we need to take that margin of error and we need to move in each direction from our sample proportion. So here's where we were. This is the formula for any confidence interval. So ignoring the 95, in fact, I'm going to move it off the screen. Any confidence interval is equal to our sample proportion plus or minus our Z critical value, which is based on the confidence level we want, times the standard error. For a 95% confidence interval, we're going to put in our sample proportion, which is 0.6, our Z critical value, that should not be a 0.2. Let me fix that quickly. There we go. So we're looking at our sample proportion plus or minus our Z critical based on 95% confidence interval times our standard error. And that standard error is exactly the same standard error that we would have come up with on the previous slide, where we calculate the standard error and we ended up with that value. When you pick up your calculator and you actually type this in, we're looking at 0.6 plus 2 times the standard error, 0.0693. And you can see that's where we get the upper limit. And we can go ahead and change that to a subtraction sign. And you can see where we get our lower limit. So what we're going to end up with here is we're going to end up with an interval. This interval tells us that if our sample proportion was 60%, or 0.6, then we believe with 95% confidence that the population proportion, the actual percent of Pequea Valley High School students who choose math as their favorite subject, is somewhere between roughly 46 and 74%. So to put it all together so you can see everything together at once, just run through the process one more time. Here it is in a nutshell. Confidence interval starts with your sample proportion and moves a margin of error in each direction. The margin of error is our Z critical value times the standard error. The standard error is the same standard error or standard deviation formula that we learned earlier in the class. If it were standard deviation, they'd be P and Q, but since it's standard error and we don't know P and Q, we're going to put some hats on those guys. Plugging in the values to find our margin of error, our Z critical is 2. Our standard error is 0.0693. Take your P hat, add your margin of error, subtract your margin of error, and you end up with a confidence interval. If we took repeated samples of size 50, 95% of those samples, if we took theoretically infinitely many samples of size 50, 95% of the time, the sample proportion would come back between these two values. So hopefully this presentation helps. You understand what a 95% confidence interval is. We're going to change it up in the next presentation, and we're going to look at maybe a 99 or a 90% confidence interval so we can understand the difference.